All right, welcome back, campers. In the last video, I said we were going to start graphing stuff, and I kind of lied. An accident. I forgot that we kind of need to go over the C value and where to get the focus points. So this will be the background on how they came into, or how you find them. So how do we find the focus points? Well, the focus points are determined by a value of C, and C has a relationship with A and B, the denominators in the equation. So we're going to use the figure to see if we can figure out what all that mess is about. So the A tells us the distance left and right from the center, and the B tells us up and down. So square root the denominators, and then the A is left and right, and B is up and down. And then the C is the distance from the center to a focus point. So that's what C is. So I can make a triangle out of this. And this is really kind of interesting. If you start to slide this focus point over towards the vertex, so if you start to kind of move this down, once this point reaches the bottom or the center, this point is going to reach the A value. So the hypotenuse of your triangle is actually A. Well, because it's a right triangle, now you can use Pythagorean Theorem. It's just going to be a little bit out of order, but you can still set it up. So it's the B squared plus C squared is equal to A squared. So this would be the equation to solve for C. So minus over the B squared, square root it, and you have A squared, roots A squared minus B squared. Now, if the ellipse was turned, if it was tall, the B value would be bigger than A. Well, if that was true, that would make your square root, it would have a negative inside of there, which is bad. So if the B value is the bigger one, this is going to get reversed. It would be B squared minus A squared. So to kind of help you out with that in general, just so you don't have to worry about well, how do I derive that again? You're going to use C equals the square root of the big denominator minus the small one. So if you follow that, then you don't ever have to worry about, well, is it under the X or is it under the Y? So just always do this. Just always make sure you get a positive result inside your radical. Okay, so let's go ahead and put everything kind of together and see if we can graph these. All right, so first things first, your equation needs to be in the right format, and if it's not, you got to get it there. So the right format is to have it always set equal to 1. That's the first thing to look for. So in our equation, it's not equal to 1. So I'm going to divide everything by 225. And then I'm going to reduce the fractions. So x squared over 25 plus y squared over 9 is equal to 1. So it's in the right format. Now I can get my center. It's right at 0, 0. The A value, look underneath the x's. Square root the 25, and that's your A. The B, it's going to come from underneath the y's and square root that. Square root of 9 is 3. So now you can get your points on your ellipse. So the center's at 0, 0. A is 5. So you're going to go left and right both by 5. And then the B values, you're going to go up and down by 3. And then just draw your ellipse as best as you can. I'm not looking for works of art, so if it's kind of lopsided, that's okay. Okay, so now you also need the foci, or those two focus points. So to get the focus, you got to find the value of C. So C, remember, it's the big denominator minus the small one. So the big denominator is 25, the small one's 9. So C is going to equal 4. And since the ellipse is a wide ellipse, that means that your focus points are going to go left and right by that C value. So left by 4, right by 4. So the focus points are at -4, 0, and +4, 0. The vertices, ran out of room. They are going left and right as well. So -5, 0, and 5, 0. And it's only the two. Don't give me all 4 of them. It's just the two that are the furthest away from the center. All right, we'll stop the video here. The next one we'll practice a couple more of those and probably also go backwards.